far as the histology is concerned. The place where the primary oocyte becomes secondary oocyte, like I mentioned in lecture, is in which follicle? It becomes the secondary follicle, secondary oocyte in which follicle? Mature follicle. And so this follicle right here, the mature follicle, is where the primary oocyte becomes the secondary oocyte. But that means that all of these oocytes are primary oocytes paused in prophase 1. In the microscope, we're not going to be looking at a mature follicle, therefore all oocytes in the microscope will be primary oocytes. It's good to just have that general rule so that you don't get confused. It's not going to be an issue of is it primary or secondary. If you're looking in the microscope, it is going to be a primary oocyte. And so then in this case, there's one layer of cells. I mentioned this in lecture. If you have one layer of cells surrounding the oocyte, they are called what? Follicular cells. And that's in that handout I gave you. So one layer of cells means follicular cells. You just have one layer. If it was more than one, then it would become granulosa cells. Good. But this is one layer of cells. This is a primordial follicle because the follicular cells are squamous. It's another thing that you would have to recognize. The follicular cells are squamous, therefore it is a primordial follicle. This one, notice these are follicular cells, still one layer, but they're no longer squamous. This entire structure, therefore, is what? It is a primary follicle. So we're looking at the second one here. It's a good thing to see the difference in this case of the primary follicle, the second one there, and primordial follicle. Notice, if we compare them, the cells there are the follicular cells, and notice they are cuboidal. So the primary follicle has cuboidal cells. The primordial has squamous cells. And this you'll see in the microscope as well. And so what you want to imagine is once you start getting FSH, follicle stimulating hormone, these squamous follicular cells will start to develop. And once they start to develop, they will become cuboidal. Now you would say development has begun, therefore this is a primary follicle. Does that make sense? Once development begins, you change the name. Primordial follicle then becomes a primary follicle. And then this follicle is destined to continue to develop or to die. And so it's not going to go back to a primordial follicle. And so there's a primary follicle. The cell there is still a primary oocyte. And then the entire structure here. Now we're going to the second one there. This second one here. This entire structure is what? How would you tell the difference between a primary follicle and a secondary follicle? The antrum. And so you would look at this, and is there an antrum here?
No.
No, so it is not a secondary follicle, therefore it's still a primary follicle. There's no antrum. That would be the way you know secondary follicle. No antrum here, there's no space that has that follicular fluid. The cells here, now there's more than one layer, so the cells are called granulosa cells. And so now you have more than one layer, so it's granulosa cells. These do the functions I mentioned in the lecture. These cells' function is to secrete estrogen, inhibin, and follicular fluid. And so when the follicular fluid collects up, it will create an antrum. And so now we can see this whole thing, a primary follicle, and notice this is also a primary follicle. And we have follicular cells here, and then when there's more than one layer, you have the granulosa cells. And so those are all granulosa cells. And now we'll kind of move to this one right here. Identify the entire structure here.
Secondary follicle.
Secondary follicle. How do you know for sure secondary follicle?
Antrum.
The presence of the antrum. Good. So you'd want to have that locked in. If you see an antrum, it then is that secondary follicle. That's what defines the secondary follicle, is the antrum. So secondary follicle because there is an antrum. And so that is the antrum right there that is blinking. And what is the fluid that would be in the antrum? Follicular fluid. Good. The follicular fluid is made by the granulosa cells. Granulosa cells would be secreting out that follicular fluid. The cell there. So this is, where does the oocyte become secondary? In the mature. So are we at the mature yet? No, still a primary oocyte. So even though this is a secondary follicle, you have to remember that all oocytes are primary oocytes except in the mature. That is probably one of the things most often missed. If you're given a secondary follicle, people like to call the oocyte a secondary oocyte, but it is not until it gets to mature. Everyone okay with that? And so, and remember, in the microscope, we're actually not even going to look at a mature follicle. So you will always say primary oocyte when looking in the microscope. The cells there are still the granulosa cells. And this is that other model, and you probably labeled this a secondary follicle. And now if we look closely, primary follicle here, secondary follicle here. Why would this be a secondary follicle in that model? What defines a secondary follicle? An antrum. And so this is the antrum in this particular model. And so when they look at if you were to look at the key for this, 13 is antrum. I don't know why the model maker did this, why they made such a tiny little antrum to define their secondary follicle, but that's what the model maker did. And so assuming that this is an antrum, this is a secondary follicle. And so because as long as there's an antrum, it'll be a secondary follicle. But you can see why I don't particularly like that secondary follicle. It doesn't show a good antrum. But that's why that is a secondary follicle. One other thing that's in the lab manual that you need to know is the theca folliculi. And so notice what we're looking at here in this model is these light blue cells are the granulosa cells, and then just outside them is a layer called the theca folliculi. The theca folliculi is divided into two specific layers. They are the theca interna and the theca externa. You have those in your list for the looking in the microscope. What I'm going to say though, because the theca interna and externa is hard to differentiate in the microscope, I'll just kind of accept for both the theca folliculi. And that's just easier than to remember. And when we look in the microscope, kind of hard to see the difference. And so together they make the theca folliculi. So therefore when you see the list and you see theca interna and theca externa, you can lump them together and say theca folliculi. I've already labeled my picture that way. So you can, when you look at my picture, what I've done, you can do that. There is a function for the theca folliculi. And I wrote them also over there, so you can copy it later. But the theca folliculi actually secretes out androgens. And so men and women have androgens. The theca folliculi secretes androgens. The androgens are then picked up by the granulosa cells here, and the granulosa cells turns it into estrogen. And so as I mentioned, the granulosa cells secrete estrogen. But what they do is they convert androgens from the theca folliculi into estrogen, and that then is how it then secretes the estrogen. So one function for the theca folliculi is to secrete out androgens. Another function is that it helps nourish the follicle. And so those are functions I put over there for the theca folliculi. And so again, you just can put interna and externa together and say theca folliculi. Everyone okay with that? So I try to simplify that a little bit. So in the microscope, you'll see that the interna, externa is kind of hard to see. And so one also thing we'll see in the microscope is the outer layer of the ovary, which is called the germinal epithelium. And so that's the germinal epithelium. One new thing also that's in the histology that wasn't in the main anatomy is this layer, just deep to that germinal epithelium, we have a tunica albuginea in the ovary. Tunica albuginea in the ovary is just like the tunica albuginea of the testis. Remember, that was this outer dense irregular connective tissue of the testis. And so what gives the ovary structural support is this tunica albuginea just deep to the germinal epithelium. And so this white layer is a layer called the tunica albuginea. Same name as in the male, same function as in the male. So I put that up on the board up there. Tunica albuginea is dense irregular connective tissue giving structural support. And so our slide number 34 is the ovary. I'll just quickly show it to you on the microscope here, and then I'll use the D12 pictures because the D12 pictures are actually of this one. So you can see on the screen, this is the ovary. This particular ovary slide has 4 specimens on it. And so you can see there are 4 right here. And what we're looking at when we look at that is all those big structures, then those are follicles. The big white spaces are antrums. And so we are looking at follicles and we're looking at lots of antrums. And so what I'm going to do is I'm going to zoom in to the very top there. And so we're looking at the ovary, we're looking at lots of follicles. I'll zoom in to where I can see the germinal epithelium. That outer kind of dark layer is the germinal epithelium. And do you see actually a secondary follicle? There's two good examples of secondary follicle there with the antrums, and we'll go over them. But I'm going to zoom in to the outer border, and that is where I see some good primordial follicles. And this is a good place to see primordial follicles, and there is a primary follicle. And so you could be given something like this in the exam, and you'd want to recognize this is the ovary. And so this is the outer, this would be where the pelvic cavity is. So this layer there is the germinal epithelium. And so the outer little layer of the ovary, germinal epithelium, just deep to it then, if it was pointed right here, this layer is tunica albuginea. Excellent. And now when we're looking at the ovary, I see some structures here. If the question was identify the entire structure, you should be thinking follicle if you're looking at the ovary. And so the entire structure here is what? Primordial follicle. The reason you know it's primordial is the follicular cells here, these are one layer cells, are squamous. Because they're squamous, this follicle is primordial. I go right below it, and this entire structure is a primary follicle. It is just still one layer of cells, but you can see now these are cuboidal. We have some development, so this is a primary follicle. And the cell at the tip of the pointer is what? This is all a primary oocyte right here. Primary oocytes are big cells. When you look in the microscope, you'll see these big cells. There's one right here. And they say that they are, you can see them with the naked eye, about the size of a grain of sand. And so they are huge cells when you look in the microscope. This is all one cell. This is the nucleus. And what specific phase is it paused in? Prophase 1. Remember, prophase 1 is where you'd actually have chromosomes, and they would be crossing over and kind of connected. So you actually see the chromosomes right there. These are the chromosomes that are, they could be crossing over right here in prophase 1. And so we have right there the one view, and that's kind of the first picture I drew. And let me show you just very close. Now I'll just go to the PDF pictures, which is very similar. And so you can see we zoom in right there. That's exactly where we were with this ovary. And so we zoomed in right there, and we can see the primordial follicle. There's a good primary follicle, another primordial follicle, germinal epithelium. If we move over just a little bit on the same slide, I can see this. And we'll just go over these ones. And so you can see these are these primordial follicles. And then we'll compare this one to this one. And so identify this entire structure. Secondary follicle. And that's a key thing to recognize. If I say entire structure, you should be thinking follicle. How do you know for sure it is a secondary follicle? Presence of the antrum. I would say identify the space there. That would be the antrum. And the fluid in there is follicular fluid. Good. The cell right here would be what? Primary oocyte. There would be a primary oocyte right there. Going over to this one and this one, identify the entire structure here. This would be a primary follicle. You'd look around and I would say there's no white space that would be an antrum. Because there's no antrum, this is still a primary follicle. What are the cells at the tip of the pointer? These cells outside, more than one layer, granulosa cells. Granulosa cells would be secreting the follicular fluid, is estrogen, and inhibin. I go over here, all of these cells also are granulosa cells. And so you can see or imagine these granulosa cells have secreted out all of this follicular fluid to create that antrum. One other thing you can see here is, on this one, notice here are the granulosa cells. Just outside the granulosa cells, there's a layer right here. So this layer is the theca folliculi. And again, you don't need to worry about theca interna or theca externa. I'm not going to hold you to those two. You just need to know together they make up that theca folliculi. So you have the theca folliculi there. You can also see here is the granulosa cells just outside of them. I'll just point there, theca folliculi. So theca folliculi is the layer outside. And then one last thing, and then I'll give you some time to look in the microscope. If I were to point here, or just say identify the specific layer on the outside of the cell, or the outer layer of the cell, the answer is the oolemma. And you have that on your list. The oolemma, and I wrote it on the board, is the plasma membrane of the oocyte. You may remember muscle cells have a sarcolemma. The axons of neurons have an axolemma. And so here we have an oolemma, and it's just the same idea. Plasma membrane of an oocyte is called the oolemma. And so I could just ask it in a way that, it's just identify the specific outer layer of the cell. So it's sometimes hard to point to the oolemma. Sometimes, and this one actually has a decent one, but it would have, the pointer could move a little bit. And so the question would probably tell you, okay, it's outer layer of the cell. I think I covered the things on the list for the first two pictures. And so what you can see, I drew my pictures. One is at the bottom of page 211. The other is on page 212. I combined primordial follicle with primary follicle, and then